Changes in state. When we talk about states of matter, we're referring to solids, liquids, and gases. As you know, these states of matter can undergo what we call changes in state, and there are 6 of them which you will recognize. Let's consider the first change in state shown here from solid to liquid. This is commonly called melting. Now let's look at the reverse, from liquid to solid. And what is this called? It's called freezing. You already know these 2 changes quite well. So let's look at the change in state from liquid to gas. What is the term for this? It's vaporization. Let me pause a moment to look at this word. Notice that it does not have the letter U in it. The word vapor has U, but not vaporization. Now, vaporization from liquid to gas has 2 forms, boiling and evaporation. In both cases, liquid is changing to gas. If the liquid is water, what are those bubbles you see in boiling? They aren't air, they aren't oxygen, they are bubbles of water vapor. The differences are that boiling is visible, it's fast, and it occurs throughout the whole liquid, while evaporation is invisible, it's slow, and it occurs only at the surface. What do we call the change from gas to liquid? It's condensation. An example of condensation is shown with this beaker of water containing ice. The ice cools the glass down until the water vapor in the air that is touching the glass condenses into droplets of water, forming beads of water running down the side. The final 2 changes are called sublimation. So solid to gas is sublimation, and gas to solid is also sublimation. Now, before I give examples, I want to note that most often water is used always to describe these changes in state. This looks like water as ice. This is water as liquid and water as a gas. But other substances also undergo these changes, and I'll show this a bit later. Let's now look at an example of sublimation from solid to gas. These are mothballs made of the chemical naphthalene. Once the package is opened, these mothballs will start to sublime from their solid state into a gas called naphthalene vapor. It never becomes a liquid, which is why the arrow passes over the liquid rather than through it. A second example is dry ice. Dry ice is the solid form of carbon dioxide, but only at very low temperatures like -70 degrees Celsius. When left open in a room, it will sublime directly from its solid state to its gaseous state. In this clip, dry ice is placed in water. The water is hot compared to the temperature of the dry ice, so sublimation occurs and now becomes visible as bubbles of carbon dioxide come off the dry ice. A third example occurs in the freezer section of your refrigerator. If ice cubes are left in their tray for a long time, the ice will sublime into water vapor in the refrigerator and the ice cubes will shrink. This picture shows a rather extreme example of it. Now let's look at the reverse, gas to solid. This is called sublimation again. The 2 sublimations are both similar in that they pass over the liquid state. Sometimes this form of sublimation is referred to as deposition, because the gas will deposit itself as a solid on the surface. One example is the frost which forms on trees. If the temperature at night drops suddenly, the water vapor, which is a gas, touches the cold branches and will sublime immediately from its gaseous state to solid frost. This is also known as hoarfrost. Another example is the frost that can be seen on telephone lines. A final example is a demonstration that involves iodine. Here's a beaker containing solid iodine at the bottom. This is pure iodine. It's a gray metallic solid, but it's hard to see here. The purple color is the vapor, not the solid. Here's a better picture of pure iodine, metallic gray color, and solid. Not the yellow liquid found in a bottle in the medicine cabinet. That is a solution of iodine, either in alcohol or in water with another compound. Here is a hot plate which will gently heat the iodine, and here is a round bottom flask to provide a cooler surface for the purple iodine vapor to contact. By gently heating the solid in the bottom, the solid will sublime into a purple vapor and rise up until it contacts the bottom of the flask. Since the underside of that flask is cooler, sublimation occurs again, this time from the gas directly to solid. And these beautiful solid crystals can be seen on the bottom of the flask. The interesting thing in this case is that both forms of sublimation can be seen occurring at the same time. So these are the 6 changes in state that you should know. The last part of this video deals with some terms that are sometimes used interchangeably in English, but in science there is a distinction which I'll now describe. The first one is the difference between freezing and solidification, and the second is between vapor and gas. First, freezing. Freezing and solidification both refer to the same change in state. The change is from liquid to solid, but there is a slight difference in how they are used. We use the word freezing for substances that are liquid at room temperature. For example, we say water freezes. We don't say water solidifies, even though it does become solid. You're already familiar with frozen icicles and ice cubes. We say alcohol freezes, and we say mercury freezes. Mercury at room temperature is a liquid, as shown in this thermometer. But if you go to a low enough temperature, minus 40 degrees Celsius, it becomes solid. This clip shows how mercury can be frozen using ice. The metal mercury is a liquid at room temperature and so is easily poured. Dry ice is cold enough to freeze the mercury into a solid. Here it is, solid, shiny, silvery metal mercury. Now let's look at solidification. We use this term for substances that are solid at room temperature. For example, we say that molten glass solidifies. When you heat glass, it will melt, and then when it changes back to solid, we say it solidifies. Similarly, when you light a candle, the wax will melt, and then when it goes down the side and becomes a solid, we say the wax solidifies. And finally, molten iron also solidifies. Iron can be heated high enough until it melts and becomes molten iron. When it is poured out, it cools down and becomes solid, as shown in this clip. So that is the distinction between freezing and solidification. Now, vapor and gas. Vapor is defined as the gaseous state of a substance that is normally a solid or liquid at room temperature. Now, that's quite a mouthful, so let's break it down. First of all, the gaseous state is a state of matter. When the gaseous state is produced from a solid or from a liquid, we call it a vapor. Here are some examples. We talk about water vapor. We don't say water gas. We talk about alcohol vapor, not alcohol gas. And we talk about gasoline vapor. These 3 substances are liquids at room temperature. If we take iron, which is a solid, and heat it up high enough, it will melt, and its iron vapor will rise up from the surface. The chemical naphthalene, which is an ingredient in mothballs, is solid at room temperature, so we call its gaseous state naphthalene vapor rather than naphthalene gas. Now, although the last two were solids, the term doesn't refer to just any solid. For example, tables and chairs don't produce vapors when heated. They will have to burn first, which of course would destroy the material. But we can do this with metals, like iron, shown here. Now let's look at the word gas. A gas is the gaseous state of a substance that is normally a gas at room temperature. Notice that it is the gaseous state, just like with vapor, but it comes from the substance that is already a gas at room temperature. For example, we speak of oxygen gas, nitrogen gas, carbon dioxide gas, and chlorine gas, because at room temperature they're already gases. Gases are also invisible, like most vapors. One exception is chlorine gas, which has a faint yellow-green color. So that's the distinction between vapor and gas. And this ends the video on changes in state.